Good morning, children. Hope you were able to do the numericals based on pressure. If you have any doubts, you can ask in the Zoom class. Remember, your copy work must be complete before you come to the Zoom class. I will be checking randomly. Today, turn to page number 52. Okay, page number 52. We're going to start the next topic called liquid pressure. Liquid pressure. Okay. Now, so far, what you saw is pressure exerted by solids. Okay, pressure exerted by solids. All the examples that you saw, everything is pressure exerted by solids. Okay, coolie carrying a load and all that. In all these cases, pressure was exerted by solids. Today we are going to see pressure exerted by liquids. Okay, pressure exerted by liquids. Now the main difference between pressure exerted by solids and liquids is solids exert pressure only at the base. For example, if I keep this object, okay, if I suppose keep this object on the book, okay, only the base of this is touching it. Okay, so solid can exert pressure only at the base. It cannot exert pressure at the sides. Okay, it cannot exert pressure at the sides. It can only exert pressure at the base because of its weight. Okay, but it is not the case with the liquids. Why? You know that in liquids, molecules keep moving and they keep hitting the sides of the container. They keep hitting the bottom as well as the sides of the container. So, pressure will be exerted at the bottom, of course, plus it will exert pressure at the sides also. Okay, so pressure exerted by solids can exert pressure only at base. Only at base. Whereas liquids can exert pressure at base as well as sides. Can exert pressure at base as well as in the sides. This is the main difference that we are going that you have to remember before starting the chapter, starting this topic. Okay, now how does liquid exert pressure, or why does it exert pressure? Now suppose you take a beaker having water. Now if I want to measure the pressure exerted on this, at this part, base, okay, now because this liquid that is above has a weight, okay, it has a weight and therefore it exerts a force or thrust, okay, it exerts a force or thrust on the base, and that is why it is exerting pressure. When you talk about pressure exerted at the sides, if you take this height, okay, at this height, the water that is above it, okay, the water that is above it will exert a pressure here. Same way, because these molecules are constantly moving, they'll be hitting and they'll be exerting a pressure on the sides also. Okay, so this is just a brief idea about liquid pressure. Now let's study from the book. So, they've given the definition of liquid pressure. A liquid contained in a vessel exerts thrust at all points below its free surface and thus exerts a liquid pressure. So, a simple example would be this activity. Okay, you have a glass tube kind of a thing which is open at the end part. You tie a balloon or some elastic kind of a thing. Start pouring water into it, and what will happen? The balloon starts expanding. Why? The water exerts a pressure because of which the balloon starts expanding. Right. Now, the next thing you should know is liquid exerts lateral pressure too. As I told you that liquid can exert pressure at the sides as well. This pressure, the pressure exerted by liquid on the sides is called lateral pressure. Lateral pressure. Okay. This is pressure at base. This is called pressure at base. The pressure exerted at the base is pressure at base. Whereas these pressure exerted at the sides are given a special name called lateral pressure. Remember that. So if they ask you define lateral pressure, the sideways pressure of a liquid is called lateral pressure. You can write the whole thing. Liquids not only exert pressure at the bottom but also exert pressure on the walls of the container. The sideways pressure is known as lateral pressure. Sideways pressure is known as lateral pressure. So this will be the definition of lateral pressure. Okay. Next heading. It's given factors affecting. You can change it to properties. It's not affecting. Properties of liquid pressure. Properties of liquid pressure. We're going to see some properties. Property number 1, the statement will be higher the density of the liquid, higher will be the pressure. Higher the density of the liquid, higher will be the pressure. Now, this can be proved by a simple experiment. You take 2 tubes of the same length, glass tubes, open at the base. Okay, it's open at the base, and then you connect 2 balloons to the open end and tie it tightly. Then you start pouring water in one thing, another one you pour kerosene. Okay, water in one of the tube and in the other one kerosene. Now, as you keep pouring, the balloon is going to expand, and you will see that the balloon under water expands so much, whereas the balloon under kerosene has expanded only little bit. Why is it so? Because they both have different density. Kerosene's density is less than water density. Okay, kerosene's density is less than water's density. Okay, so water is denser than kerosene, or kerosene's density is less than water. Therefore, this density is less, so it exerts less pressure. Water's density is more, so it exerts more pressure. That's why it bulges more. So this is your property number 1. Higher the density of liquid, higher will be the pressure. Now we go to property number 2. Pressure at a point inside a liquid increases with the depth from the free surface of the liquid. I'll explain it, then it will be easy for you to understand. You can even try this experiment at home. So this is a transparent bottle. Okay, I can take water in this, and you can put 3 holes at 3 different heights. 3 holes at 3 different heights. Okay, now you pour water till this, and what will happen? Water is going to come out of these holes, right? Water is going to come out of these holes. Now, what will happen? You can try it practically. What will happen is, so it's having water. You put 3 holes, one here, and one here. Okay. Now water is going to gush out of all the 3. Now the water that is coming from the lowermost one will be falling at a far away distance, whereas this will be coming somewhere here. The water coming from here will fall here, whereas the water coming from the top will fall very close to the base. Why does this happen? Why do this one fall at a larger distance, this one little less, and this one very less? It's because the pressure of the water coming from here is very high when compared to the pressure of water coming from here. Okay, pressure of water, because this is at a greater depth. Okay, or you can say depth. This depth is more than this depth from the surface, from the free surface. From the surface, if you see, this layer's depth is very less, whereas this layer's depth is so much. Because of this, means so much water is exerting pressure at this level, so the pressure is so high and it falls here. Whereas in this case, only the water that is above is going to exert a pressure which will be less. Therefore, the pressure is not going to be so high, so it will just fall very close to the base. Hope you understood this. You can try this by yourself, children. So, the conclusion is property number 2. Pressure at a point inside the liquid increases with the depth from the free surface of the liquid. You have to memorize the whole sentence. Okay, the same thing they have given it in a little explained form. Activities, they generally don't ask, but you can just read it once and leave it here. Okay, just read it, go through it once, and you don't have to memorize it, but it will help you to understand the concept. Property number 3. Liquid pressure remains the same in all directions at a given depth. Now what they are saying, at a given depth, pressure remains the same. Now for this, what you can do, you take another box. I've taken another transparent box and I've drawn a straight line. Okay, I've drawn a straight line. Now in this, at this line, you put 2-3 holes. Okay, maybe you can put 3 holes. At the same level, I'm putting 3 holes. As usual, I pour water and water is going to come out. Now, because these 3 holes are at the same height, the water coming out of all the 3 holes will be falling at a same height, in the sense at the same place. So, it's like from this point, I put 3 holes. So, the water coming out of all the three will be falling at the same place. What does it mean? Not exactly at the same place. The distance, maybe this is falling here, but the distance from the base will be the same. Hope you're able to understand. So the water will be coming out of it, but the water coming out here, the water coming out from this may fall here, water coming out from this small here. The distance is the same. The distance from the base will be the same. That means the pressure of the liquid coming out of all these 3 is the same. Hope it is clear, children. So that is property number 3. That is, liquid pressure remains the same in all directions at a given depth. At one particular depth, in all directions, at all points, liquid pressure remains the same. Okay, so that's the third property. Now there is one information or one reasoning question that you should know. This is based on this, that pressure increases with depth. Have you all seen the walls of a dam? Generally, now usually any wall you see, it will be like this. It will be like this, right? Bricks here and all that. Whereas the wall of a dam will be like this. Okay, so this will all be bricks and all that. Okay, why is it so? The base of this dam is broader than the top. The reason being, so what is a dam used for? To store water. Now, water will constantly exert pressure. Okay, so water will keep hitting this and they keep exerting pressure. Okay, now at this point, if I take this much height of water will exert pressure. Okay, at this pressure at this point, if I take this much height of water is going to exert pressure here, and at this point this much height of water is going to be exerting pressure. That means as you go down and down, the pressure on these walls are going to keep increasing because their depth is increasing. Therefore, the pressure exerted on the sides will be very high, and that can lead to damage of this wall because constantly they'll keep hitting. So to withstand that pressure, okay, not to just get crushed under that pressure, they keep it broader so that they don't get damaged. Okay, children. So this comes in, also comes in reasoning question. Walls of the dam are made much more thicker at the base than at the top. It is done because pressure of stored water is maximum at the base. To withstand such high pressure, they are made broader at the base. Okay. Okay, next we go to the property number 4. A liquid seeks its own level. Property number 4 is liquid seeks its own level. Now, this can be proved, it's a special apparatus. It's called, this is the apparatus. You have different tubes of different shape, glass vessels of different shapes. Okay, these are all different shape. All of them are connected together at the base by a common tube. Okay, all of them are connected together at a common tube. Okay, so one will be like triangle, one will be like this. Okay, one can be like this. So maybe I'm just drawing 3. Okay. Okay. Now I'm pouring water into this one. Now what will happen? Do you think the water will fill in this first? Then it will go here to fill this. Then once this gets filled, then it goes here. No. The answer is no. Why? As you pour water, how much ever water you are pouring will be distributed equally, and the level will keep on rising to the same level. Okay, so at a point, if you see, as you're pouring water, the level of water will be the same in all the three tubes. Though they are of different shape and size, the pressure, the level of liquid at all the 3 tubes will be the same. This property of liquid is called liquid seeks its own level. It will maintain the same level irrespective of the shape and size of the container. Okay, so that is property number 4. Now property number 5, liquid pressure at a point does not depend on the shape and size of the container. Okay, this is also based on the previous activity. Liquid pressure does not depend on the shape and size of the container. Also, it is independent of the surface area. It can be broad or it can be a narrow one. That doesn't matter. It's only the height of liquid that matters. Hope it's clear, children. All these 5 properties. Okay, state all the 5 properties of liquid pressure. If they ask, you should write all the. Okay, next we go to the formula. The formula used to find pressure exerted by a liquid column is given by P is equal to H into D into G. P is the pressure exerted by the liquid. H is the height of liquid column above that point. G is acceleration due to gravity, and D is the density of liquid. Okay, suppose if I have a container like this. I have to, okay, it is having liquid till this, and I have to find the pressure exerted by this at the base. I want to find this pressure exerted by the liquid at the base. So pressure will be height of the liquid. Okay, this height I should take, that is H, into density of liquid. Every liquid has a particular density. So that's why D into G. G is acceleration due to gravity. So that you will see in detail later, but just now you remember it. So if they ask you the formula for liquid pressure, you will write P is equal to HdG, and you have to explain all these things. What does P stand for, D stand for, H stand for, and G stand for. And the last part is consequences of liquid pressure. Okay, this often comes in reasoning question. The first consequence is deep sea divers wear a special type of suit. You would have seen this, no? Deep sea divers, when they go deep inside the sea, they have to wear a special suit. Why? As they go deeper and deeper, pressure exerted by water keeps increasing. Okay, pressure exerted by water in a sea increases with depth. Deep down the water pressure is very high, and so what it can do? It can crush the bodies. Okay, so the man's body is here, but the outside pressure exerted by the liquid will be so high. Okay, something like this. The man's body is, okay, suppose if it's his body, from outside, okay, suppose you take this as the man's body, and he is deep inside the deep inside the ocean. So water, as he goes down, the depth increases, so the pressure exerted also increases. So if the pressure becomes so high, it can crush his body. It can crush his body. To prevent this, he has to wear a special kind of suit that will help him not to get crushed under the pressure. Okay, so that is one thing, and it all comes in reasoning question. Why do deep sea divers wear a special type of suit? Answer will be pressure exerted by water increases with depth. Deep down the water, pressure may be so high that it may crush the human being, and therefore to withstand such high pressure, and for divers to remain safe, they wear that. Okay. The next consequence is submarines are built of hard, thick sheets of special steel alloys. Why? Okay, you know what is a submarine? It can go inside water and also it can float in water. Okay, so when they go inside water, as again same way as they go deep inside the sea, okay, as they go inside and inside, it can go deep inside the sea, the pressure will keep on increasing and it should not get crushed. So they wear the body of the submarine is made of hard, thick sheets of special alloys. Again, reason is withstand the high pressure under seawater. Another possible reasoning question is, deep sea fishes may burst when they are taken out of water. Some deep sea fishes, okay, deep sea fishes, if you take them out of water, they will die. Why? Their bodies generally have a very high blood pressure. Okay, so because they live deep inside the water, they have to, the outside pressure acting on them will be very high. So generally their body pressure, blood pressure, okay, the pressure of their blood is high. When compared to the other fishes at the top, these fishes, their blood pressure is high. Okay, so because so that they can withstand this, they are meant to live here at the deep seas. Okay, by chance, if they are brought out, okay, somebody did a fishing and it brought this fish out. Usually they say they won't remain alive in the shore for a longer time. It's because their inside pressure, the blood pressure is so high. When they come to the surface, outside pressure will be less when compared to the blood pressure. Okay, the outside pressure. So the blood pressure is high, whereas outside pressure is less. So what happens? Their body will burst. It's like from here, from inside, something is pressurizing it, so the fish might even burst. Okay, a fish here, when it goes inside, it can get crushed, and a fish that is down, when you bring it outside, it gets burst. Hope you understand these two things. Okay, so the reason will be deep sea fishes generally have a high blood pressure due to the pressure of seawater. If such fishes are taken out, external pressure on the body decreases suddenly. As a result, they may burst. Okay, so that's all for today, the teaching work. I would like you to turn to page number 59. Page 59. And till 8 you have done. Strike off question number 9 and 10. But I am giving you alternate questions. Instead of question number 10, you can note this down. Define lateral pressure. Note it down. Define lateral pressure. You can pause the video and please note it down. Then question number 10, because these are activities, generally they don't ask activities. Okay, question number 10, give the formula for pressure exerted by a liquid column. Give the formula for pressure exerted by a liquid column. As I said, you should write the formula, and also you should write what each stands for. H stands for P. The whole thing you have to, the whole thing must be written. Okay. Then 11th one, explain that liquid seeks its own level. Okay, with a diagram. So you have to draw that apparatus, the connecting, the special apparatus that I was explaining to you. So with the help of this only you can explain. So 11th and then 12th again I want you to state two factors, strike two factors and write 5 properties. State the 5 properties on which pressure at a point inside a liquid depends. Is it clear, children? So you'll write the answer for these questions 9, 10, 11 and 12. Thank you, children.